All right, everybody, this is a 5.3 or section 5.3 exponential functions. All right, so this one we're going to talk about what an exponential function is, the graphs, and a little bit how to actually solve for these type of stuff as well. Okay, so first off, we're just going to talk about the definition of an exponential function. Okay. So the definition of exponential function is the function f of x is equal to a to the x power, where a is some number bigger than 1. Okay. Or essentially, it could be non-zero because we're going to deal with fractions as well. So I guess if it's easier, we could say a is non-zero or just 1 or more itself. That gives you the exponential function, or actually less than 0. Yeah, oh, yeah, that would be good when it comes to it. Okay. Right. So when it comes to these things like this, well, we want to figure out, well, how do we graph these type of portions, okay? So first off, let's just say, what would the graphs actually look like? So we'll just start with a small example of f of x to the 2x power, okay? So we're just going to graph this the old-fashioned way, just make a little t-chart and so forth down the line, okay? So in this case, right, we plug in some numbers. So let's plug in, let's say 2, 1, 0, and some negatives as well. Okay? So if we plug them in, 2 squared gives you 4. 2 to the first power gives you 2. Trick question, if you guys remember, 2 to the 0 power actually gives you 1. So quick little note when it comes to it, little sidebar. Any number to the 0 power always equals 1, right? It's just a property based off that, okay? And the other property we're talking about is the next two is if I have a to the negative, let's say n power, this is the same thing as 1 over a to the n power, remember? So if you have a negative power, you actually can flip it to the bottom of the fraction and make it positive. So that's kind of what we're going to be doing here, because now if we have 2 to the negative 1 power, that's saying 1 over 2 to the first power, which is just 1/2. Okay, so same thing applies for the second one. So 2 to the negative 2 power, this is 1 over 2 squared. All that does is make the power positive, not negative, right? So that becomes now a positive 1/4. So you should actually have never negative values here, which is an interesting part about it. So if we graph this portion now, let's see how this is going to look like. So first is 2, 4, 1, 2, 0, 1, negative 1/2, and negative 2/4. So the graph actually looks like this. And this shoots up on the other side. So I always make a joke that, this is what you want your bank account to look like, right? Exponential growth, meaning it just shoots up no matter what, and it's, make millions and millions of dollars, not the other way around. So that's portion. So essentially, if I have the general graph of a to the x, well, that means it's going to look like that portion here, right? Where a is any number, I can make it 3. All it's going to do is tweak the graph because, now it's being to, 3 to some power instead of just 2 to some power. Okay, so that's that portion here. Now we want to figure out, well, what happens if, a is a little smaller than 1, right? So I said it has to be bigger than 0, or actually, let's make this bigger, 0 instead of 1. Make it bigger than 0. So if I do that now, well, what if I have this? F of x equal to 1/2 to the x power. And now we want to see what's actually the difference between here, right? So this one, when it was a whole number, it looks like this, and it's going to be an arbitrary general term. But now what happens if it's a fraction? Well, the good thing is we're going to do the same thing. We're just going to graph it and see what we get. So let's make another t-chart, and we can use the same numbers to help ourselves out. Okay. So if I plug in 2 now, 1/2 squared is going to be 1/4. 1/2 to the first power is going to be 1/2. And 1/2 to the 0 power is still going to be 1, right? Because of portion. So if you kind of notice, it kind of goes the opposite direction, right? Because now if I plug in -1, it's a little trick question, right? Well, because it's a negative, that means everything is flipped. So I just get 2 itself. And same thing applies on the other one. So if I have 1/2 to the negative 2 power, that means I flip everything, and now I square it. Well, 2 times 2 is 4, and 1 is 1, so that just becomes a 4. So literally everything just flips completely around. So let's see what's actually happening here. All right, so this time we have 2 and 1/4, 1 and 1/2. So they have this in common, 0 and 1, -1, 2, and then finally -2, 4. So it goes in the opposite direction, as we can see. So, right, so probably you guys' bank account when, Christmas hits, right? Because, it just drops dramatically because buying presents for everybody, right, when it comes to it. Now, this again is a very important one because this is going to be in general. If I have, 1 over a to the x power, it's going to follow this exact same template. So the general term, if a is a whole number, is going to look like that. And if a is if the fraction is a fraction, like, when it comes like this, it's going to look like that. It's just a complete reverse of it. Okay? So pretty interesting stuff when it comes to the general portions of them. Okay? Now, also, if you guys notice, we actually have a horizontal asymptote when it comes to it. So let's just talk about, let's just do some general properties. Okay. So first general property is if the graph looks like this, right, if I have a to the x power, where that means it's going to look exponentially going across like this. And if the graph is a fraction, then it's going to go in the opposite direction. Just quick little summary, right? Goes in the opposite direction. Now, the third major part is it has a horizontal asymptote at the value y equals 0, right? Because the horizontal asymptote means it does not cross the x-axis. So the cool thing about an exponential function, technically, right, the general term is it never crosses the x-axis, meaning it's never negative. That's the most interesting part. It gets very, very, very close to 0, but actually never touches it. Later on in the course and in calculus, you'll see taking limits as to why that actually corresponds to. It's pretty interesting stuff as it goes. Okay, so a little precursor into calculus you guys will be doing next semester or wherever you guys take calculus. So those are the three major properties when it comes to the general functions for exponential so far. We're going to add on top of this, but before we actually add on top, just a quick little rundown when it comes to it. Now the whole goal is actually graphing these type of graphs of different situations, right? So quick little review when it came to it. Do you guys remember when we had this? Oh, actually, okay, 4. Okay. And remember, we graphed these using transformations. And if you guys remember way back in chapter 3 that, we wanted 3 numbers, A, H, and K, told you how the transformations actually came. So in this case, A would be 1, the number in front. H would be positive 3, and then K would be positive 4, right? And then we use the transformations using our parent function itself. Now the thing is, our general functions of a to the x and 1 over a to the x are also going to be our parent function itself. So we can just add 2 more parent functions to what we have begin with in chapter 2. So these are going to be our new parent functions. And the good news is these 3 numbers also do the exact same thing to these parent functions. So the rules also all apply. So which means, so if I have the general function, it looks very similar to this. Right? Notice the H and K is a little off than what we expect, but they do the exact same property, which means H moves it, shifts it left to right, and K moves it up and down accordingly. So it's the exact same rules as we did before. So if we do this general term, we have our parent function, and we get our graph our parent function here, right, just like we did before. And again, still using these transformations, x will always be added to h, and y will always be added to the k value. Now, the only thing you got to be careful of is the signs itself. So in most cases, you're going to have a negative out here or a negative out there, and then that still corresponds to the same value, right? So if the number's in here, that changes to 1 over times 1 over the number here times x. If there's a number out here, you multiply by the y on the bottom. So the exact same rules apply as we did in chapter 2. Okay, so let's try some examples out so you can see, using the exact same rules as the general function here. Okay. So let's graph this using translations, meaning we're actually not going to be plugging in, a calculator into itself, right? We're using transformations. So first off, we're going to draw our parent function, right? And the parent function is the bare basics. So this is just b2 to the x power, right? So we can use the same ones we did before. We use 2, 1, 0, -1, and -2. And I'm just going to write them down because we did them earlier. Okay. And now using our general transformation, we're just going to figure out the three numbers, the a value, the h, and the k, right? Associate. Now remember, little trick question, because I know it's kind of funky. Remember, this is technically the a, but the a value is still going to be in the front number. So these two is going to technically our a term as according to the associated here, not the actual like 2 in this case, okay? So if we do that, we technically don't have an a value. It's just going to be 1 because there's the one in front of the 2 and the front of the x is just a 1. So we can figure out what the h value and the k value is going to be. So remember, the h value is always attached to the x, and the k value is always by itself. So that's easy to figure out. It's going to be 1. Now just remember, right, the rules were if it's plus 2, your h is going to be the opposite. What you see is going to now be -2. Okay? So remember, it's always opposite sign when it comes to the h values themselves. Okay? All right, so now we can use this transformation corresponding to it. So using this transformation now, for all the x's, we're going to subtract 2 because that's what the h tells me, subtract 2. And for all the y's, I'm going to be adding 1, right, the k value itself. Okay, so let's do that. So every number here, we're just going to subtract 2 just like a function, right? So 2 minus 2 gives you 0. 1 minus 2 gives you -1. 0 minus 2 is -2. -1 minus 2 is -3. And then finally, -2 minus 2 gives you -4. Okay, and now we do the same thing for the y's, except now this time for every y, I'm just going to be adding 1. So 4 plus 1 is 5, 2 plus 1 is 3, 1 plus 1 is 2, 1 half plus 1 is technically, if you want, you could do just 1 and 1/2 if it's easier for you. This is 1 and 1/4. You don't have to give it, or you could just give it the decimal, whichever you prefer. Okay. And now this is actually what we want to graph. That's the main focus. So now this is what we actually graph. Okay. Right, so we graph, so 0, 5, so 1, 2, 3, 4, 5. -1, 3. 2, -2, 2. -3, 1 and 1/2. And -4, 1 and 1/4. So it looks kind of like that. Now notice, right? Well, now it doesn't get any lower than this. So the question now becomes, what line does it shift? Because everything is moving, which means now our horizontal asymptote is actually not 0 anymore because, it never even gets close to 0. The question now becomes, where does it actually go? And believe it or not, it doesn't cross this line here. Well, that's the line y equals 1. So in fact, when it comes to the general population, right, so we can add one more portion when it comes to our properties. And so in general, our horizontal asymptote will always be the line y equals k, depending on how far we go. So in this case, since it's y equals k, and the k value is 1, our horizontal asymptote is a line y equals 1, right? It does not cross the y equal 1. All right, so let's try one more example so you guys get a little hang of this as well. So let's graph this one. So when it comes to our parent function, P for parent function, this is going to be just a regular 1/3 to the x power, right? The bare basics that we have here. So this one we haven't done before, so we're just going to make a little t-chart for this one. So not too bad, right? And we'll use the same one. So you can always use just 2, 1, 0, -1, and -2 as your x's. That will never fail you here. So when I plug in, right, this is going to be 1/9. This is 1/3. This is still going to be 1. And remember, the negatives flip it. So you actually get 3 and then 9. So if it's easier, right, they're going to be the opposite. So if you start with fractions, you're going to end it with whole numbers, with non-fractions as you go to the negatives. So, okay. All right, so now we're going to do this transformation. Again, we got to figure out what is our 3 letters. So this time, we do have an A though, right? So first, easiest one is K, right? It's going to be -3. H is going to be opposite sign, so -2. And now the A term is technically a -1, right? So there's a number in front of the x value. Okay. Now remember the rules. I said this earlier, right? If there's a number in front of the x here, it gets reflected across the x-axis, so therefore it's going to be changing the x, not the y. If there's a number negative out here, that will be changing the y values itself, that when it comes to that transformation. So when it comes to this, now I'm going to have, for every x, I'm going to be minusing 2, because that's what the h is. And for every y, I'm also going to be minusing 3, because that's what the h is, the k is. Now, since this a is attached to the x, I have to pop a negative in front of x first. So I have to multiply, then subtract the 2 first. That guarantees you the complete transformation itself. So now when we want to graph our child function, so first off, you're going to pop a negative in front of all these and then minusing 2. So in this case, it's going to be -2 minus 2. So -2 minus 2 gives you -4. -1 minus 2 is -3. 0 minus 2 is -2. Be careful, negative makes a +1, minus 2 is -1. And then finally again, negative makes it positive. 2 minus 2 gives you 0. So that's how you do the x-axis, because we have this negative in front of it with the x's. And now for the y's, we simply subtract 3 essentially. So 1/9 minus 3 gives you -2 and 8/9. Subtracting here gives you again -2 and 2/3. 1 minus 3 is -2. 3 minus 3 is 0. And then 9 minus 3 is 6. And there we go. Now we got our points. So now we graph them and we're done for there. Okay. So first point is -4 and -2, 8, 9. So pretty close to 3. So you're roughly there. -3 and 2, so it's getting close to -2 now. -2, 2. negative 1, 0, and it shoots up from 0 to 6. Now the question becomes, how far do I go down, right? So for that, we got to figure out what is our horizontal asymptote. So horizontal asymptote, right, in general is y equals the k value. In this case, the k value is negative 3. So it should never go under negative 3. So if it's easier, you can make a line illustrating our horizontal asymptote. So it should not cross that. So you should be down going this way, right? You should be flattening because of that. So this is roughly our sketch of a graph of this function. Okay. All right, so I've been 20 minutes. It's a little longer than I thought it would be. Next video, we'll talk about the different types of numerical values of E and then a little bit of solving as well.